My name is Muhammad Shafiq bin Muhammad SHOKRI. I want to tell about the objective of this project is to design a synchronous counter with the irregular binary count sequence by using JK flip-flop. From this project, we can better understand synchronous counter as we repeatedly make reference from book and note from the internet. We can determine the number of flip-flop and construct the state diagram and build truth table from transaction table. We can obtain simplified equation by using KMap, and we can draw the logic diagram when we obtain simplified equation by using KMap. Next, I want to tell about the introduction. The counter is a sequential circuit that goes through a prescribed sequence of state upon the application of input pulse. The input pulse, called counter pulse, may be clock pulse, and they may originate from internal source and may occur at prescribed interval of time or at random. The sequence of state in a counter may follow a binary count and any other sequence. Counter can be implemented using a number of flip-flops that are connected to give required function. Each flip-flop is used to represent one bit. The number of flip-flops the counter depends on type of the counter. Counter that has n flip-flop can be designed. Synchronous generally refer to something which is coordinate with other based on time. Synchronous signal occur at same clock rate and all the clock follow the same reference clock. In synchronous counter, the clock input across all the flip-flop use the same source and create the same clock signal at the same time. So, a counter which is using the same clock signal from same source at the same time is called synchronous counter.
Okay, my name is Muhammad Aziz bin ZULHAIRI. Now I will continue with theory. A synchronous counter are so called because the clock input of all individual flip-flops within the counter are all clocked together at the same time by the same clock signal. In the previous asynchronous binary counter tutorial, we saw that the output of one counter stage is connected directly to the clock input of the next counter stage and so on along the change. The result of this is that the asynchronous counters suffer from what is known as the propagation delay, in which the timing signal is delayed a fraction through each flip-flop. However, with the synchronous counter, the external clock signal is connected to the clock input of every individual flip-flop within the counter so that all of the flip-flop are clocked together simultaneously in parallel at the same time, giving a fixed time relationship. In other words, change in the output occur in the synchronization with the clock signal. The result of the synchronization is that all the individual output bits changing state at exactly the same time in the response to the common clock signal, with no ripple effect and therefore no propagation delay.
My name is Muhammad ASYRAF bin Muhammad UDANIS, and I will continue about result and discussion. Result and discussion. Synchronous counter analysis. This is truth table for our project. We are using KMap to create the equation that we need. For the first table, we get JA equals to 1 and KA equals to B C bar plus C D bar. Next, JB we get C bar plus D, KB equals to 1. JC equals to B, KC equals to B, and JD equals to AC, while KLD equals to A. Next, I will show our circuit for this project. This is our project. This is our circuit for this project and the data output. Next, I will show the simulation of the circuit. That's how our circuit is functioning. Discussion. This project is about to design a synchronous counter which the irregular binary count sequence by using JK flip-flop. Our group need to study about JK flip-flop to make sure we all can design a synchronous counter. There are a lot of steps to design a synchronous counter that need to be understood. To create a synchronous counter, we need to combine a JK flip-flop to make it happen. In this project, we are using JK flip-flop to create a 4-bit synchronous counter. During the project, we have encountered some error that have affect the counter that it not count like the sequence that we need to design. So we all need to find the error and solve it. The error was at truth table based on the transition table. The error has been solved and the counter sequence like the question. Based on the error that we all learned, that we need the double check the truth table before we design the counter.
Okay, my name is Muhammad Kamal bin JAILANI and I will present about conclusions. Conclusion for my group is we can design a synchronous counter with irregular counting sequences using JK flip-flops. Besides, we can also understand the sign counter well. Next, with this project, we can create a circuit based on given binary number. In addition, we can draw a logic diagram when we obtain a simplified equation by using K-maps. Finally, with the cooperation given by our team members, we managed to complete this project on time. We would like to thank our lecturer TS Dr. Azman bin Ahmed for helping us a lot in completing this project. Okay, this is my reference, books and website. Thank you.